Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on quadrilaterals. So a quadrilateral is any shape with four sides. There are heaps of different types of quadrilateral, and in this video we'll look at naming those, and we'll also look at the angle sum of a quadrilateral. So let's start by drawing any random four-sided shape. So this wonky looking shape is a quadrilateral because it has four sides. Now for any quadrilateral, no matter what it looks like, we can divide it into two triangles. So we're going to divide it like this, okay? So these two triangles aren't necessarily the same size, but remember, it doesn't matter what the size of a triangle is, the sum of its interior angles is always 180 degrees. So this angle here, plus this angle here, plus this angle here, all those three green angles add up to 180. But on the other side, this angle plus this angle plus this angle must add up to 180, because the angle sum of any triangle is 180. All the yellows add up to 180. All the greens add up to 180. So if you add all of the four angles in a quadrilateral, they will add up to 180 plus 180, which is 360. So we've now discovered that the four angles inside any quadrilateral add to 360. So the angle sum of a triangle is 180, of a quadrilateral is 360. And we can use this to find the size of unknown angles without even measuring them. Let's look at this quadrilateral down the bottom. We're going to find the value of an angle marked x. So I know that all four of these angles must add up to 360. So all I can do to find x, it's really simple. I take 360 and I minus all the other angles added together. So 100 plus 70 plus 55 is, of course, 225. So 360 minus 225, x is 135. How easy is that? So sometimes what we're going to need to do is find an unknown angle using not only the angle sum, but also some properties of the shape. So we're going to take a look at a kite. The shape in red is actually a kite. Don't worry if you didn't recognize that, because we're going to go through classifying quadrilaterals later in the video. But it's a kite because it has two pairs of adjacent sides equal. So these two sides next to each other are equal. That's what these two lines mean. And similarly, this line and this line are equal. That's what this symbol there means. Okay, so two pairs of adjacent equal sides means it's a kite. So how are we going to use that to find what y is? Well, we only have two angles and we want to find another angle. It might look impossible to you, but a property of kites is that this angle and this angle are equal to each other. Works for any kite. So to find y, I know it's going to be the same as this one here. So I have 80 plus 70 plus 2y, y plus y is 2y, is equal to 360. So 80 plus 70 is 150. So the two y's must add up to 360 minus 150. So this angle and this angle add to 210, and they're the same. So we just halve 210. Y would be 105 degrees. So let's look at this new red shape down the bottom. So this symbol here and this one here mean not that the sides are equal, that means they are parallel to each other. And similarly, this side here is parallel to this side here. So we're going to use that to find the values of x, y, and z, because without this information about the lines being parallel, we actually couldn't figure out x, y, and z. But we can figure out x straight up without using the angle sum, because co-interior angles. X and this 80-degree angle are co-interior. Remember, co-interior angles add to 180, so that means x is equal to 100 degrees because it's co-interior. So then what would y be? Well, it turns out that we can draw a C around here. Y and x are co-interior. So x is 100, but this angle, x and y, must add to 180, so that means y is also 80 degrees because it's co-interior. And similarly, z will be 100 degrees because it's co-interior to y. So we've just come up with a special property of this shape. The opposite angles are equal. Those two blue angles are equal, and these two red angles are equal. So this shape, as it turns out, is called a parallelogram, and we'll look at that now that we go into classifying quadrilaterals. So please pause and copy down this slide if you need. So we're now going to look at classifying different quadrilaterals. We're going to give the name of all the different types of quadrilaterals. So the way I'm going to go through classifying here, we're going to divide them into 3 groups. So quadrilaterals, because they have 4 sides, they can have 0, 1, or 2 pairs of parallel sides. So we're going to start at looking at the case where a quadrilateral has 2 pairs of parallel sides. So if a quadrilateral, a 4-sided shape, has 2 pairs of parallel sides, we call it a parallelogram. So this and this are parallel. That's 1 pair of parallel sides, and this are parallel. So there's 2 pairs of parallel sides. So if a quadrilateral has 2 pairs of parallel sides, it is a parallelogram. This is the shape that we just saw on the previous slide. Probably be really good for you if we could stop there, but we actually need to know the different types of special parallelograms there are. So as I said, these symbols here, they all mean that the sides are parallel. It turns out that they're actually equal anyway. This side here must be equal to this side here, and this side must be equal. That's true for any parallelogram. So if there are 2 pairs of parallel sides, then the opposite sides are equal. We also discussed on the previous slide that opposite angles are equal. This angle and this angle must be equal to each other, and this angle must be equal to each other. So these are called properties of parallelograms. They're things that are true about any parallelogram. But the definition that we're using for a parallelogram is a quadrilateral with 2 pairs of parallel sides. Okay, so what about these other special parallelograms? Well, I said that opposite sides are equal in a parallelogram, but that doesn't mean all 4 sides are equal to each other. In a normal parallelogram, this side here might not be equal to this side here. Sometimes they are, sometimes they aren't. Now, if all 4 sides are equal to each other, we have a special name for that. If all 4 sides are equal, we call the shape a rhombus. So a rhombus is also a type of parallelogram because it has 2 pairs of parallel sides. So if it's a parallelogram with all 4 sides equal, then the shape is called a rhombus. So I said before that opposite angles are always equal in a parallelogram. So this one and this one will be equal, and this one will be equal, right? But there's nothing that says all 4 angles must be equal to each other. The green angle is not necessarily equal to the black angle. When they are all equal, we give that quadrilateral a special name that you're familiar with. That's actually called a rectangle. So I know you sort of knew what a rectangle was before this video, but now we're formalizing it. A rectangle is a type of parallelogram because it has 2 pairs of parallel sides, but it is a special type of parallelogram where all of its angles are equal. Now, because the angles in any quadrilateral add to 360, if all of the angles of a quadrilateral are equal to each other, they will all be 90 degrees. So a rectangle is a parallelogram with 4 right angles. So a rectangle is not necessarily a type of rhombus because it doesn't have all 4 sides equal. These 2 sides are equal, and this side are equal, but you can see clearly that this side here is shorter than this side here. So a rectangle is not necessarily a rhombus. It is possible, however, to have a parallelogram where all sides are equal and all angles are equal. See if you can guess what that's called. You probably guessed it, that's a square. So a parallelogram that is both a rhombus and a rectangle is a square. A square is a type of rectangle, it's a type of rhombus, it's also a type of parallelogram. A square is a special parallelogram. It has two pairs of parallel sides, but it's a special parallelogram where all sides and all angles are equal. So all four of these sides are equal, that's why it's a rhombus, and all four of these angles are equal, that makes it a rectangle. So here's something that'll blow your mind. All squares are rectangles. A square is a type of rectangle, but not all rectangles are squares. So that's all I'm going to say about shapes with two pairs of parallel sides. Please pause and copy down this slide if you need. So that's all for two pairs of parallel sides. What about a quadrilateral with one pair of parallel sides? Well, it's actually a lot simpler. There's just one name for it. There's just one type of quadrilateral with one pair of parallel sides, and it's called a trapezium. You might also see it called a trapezoid, but I'm just going to stick with trapezium. So what do they look like? Well, they look like this. They have, sorry for my poor drawing, one pair of parallel sides. So these two sides are parallel but not equal. So obviously this line here and this line here are not parallel. So this has only one pair of parallel sides. It's a trapezium. Trapeziums can also look like this. So it has one pair of parallel sides. Once again, there's not necessarily any equal sides. A trapezium may have one pair of equal sides, but usually doesn't. So if it does have a pair of equal sides, we call it an isosceles trapezium, just like we called a triangle with two equal sides an isosceles triangle. So if it has two equal sides, it'll be those two there. So that's what a trapezium is. It is a quadrilateral with one and only one pair of parallel sides. It may have a pair of equal sides. So I'm going to get rid of this. Please pause and copy down if you need. Now I'm going to go through the case where there are no parallel sides. So sometimes what you'll have is a wonky looking quadrilateral like this. That's two sides, three, four sides, for example. That doesn't have a special name. It has no pairs of parallel sides. It may have some equal sides, but we don't really care. We just call this an irregular quadrilateral. Irregular quadrilateral is the name we're going to give to any shape that doesn't fall into any of the previous categories. It's not a trapezium, it's not a parallelogram, which means it's not, a rhombus, rectangle, square, or whatever. But there is one other shape that might not have any parallel sides, and that one's a bit tricky. Seen this shape before, it's a kite. So adjacent sides are equal and these two angles are equal. So a kite doesn't necessarily have any parallel sides. However, what's confusing is sometimes it does. So a general kite has no parallel sides unless it is a rhombus. A rhombus is actually a type of kite. So a kite will either have 0 pairs of parallel sides, that's just a normal kite, or it will have 2 pairs of parallel sides if it is a rhombus. So you can tell the difference between a kite and a regular quadrilateral easily. As I said, a kite has to have 2 pairs of adjacent sides that are equal, sides next to each other. So these 2 yellow sides are equal, these 2 sides I'm marking red are equal, and it also has this pair of equal angles, as opposed to the irregular quadrilateral, okay? But what makes a kite confusing, usually they have no parallel sides. The only time a kite will have parallel sides is if it is a rhombus. So a rhombus is a shape that is both a kite and a parallelogram. You can also think of a rhombus as a kite where all 4 sides are equal. So a rhombus will be something like this, where all 4 sides are equal, and because of that, it will have 2 pairs of parallel sides. So sorry for the confusion. All right, there's one more thing we have to do, and that's go through convex and non-convex shapes. Please pause and copy this down if you need. So the last thing we have to do is classify quadrilaterals as convex or non-convex. So a convex quadrilateral means that all the vertices, which means corners, point outwards, that the diagonals are inside the shape, or that it has no reflex angles. If any of those is true, the shape is convex. So I just put the definitions here for you in case you don't know what a diagonal or a reflex angle is. But as usual, it'll be good if we look at an example. So it turns out that all the special shapes we looked at are convex. So kites, rhombuses, squares, rectangles, parallelograms, they're all convex shape. In fact, if the shape is non-convex, then it's like that irregular quadrilateral that I drew. So this red shape here is a parallelogram. So it is convex. You can see all of its vertices are pointing outwards. They're pointing away from the center of the shape. So that's one reason why it's convex. Now the diagonals are inside the shape. So a diagonal is a line that joins non-adjacent vertices. Adjacent means next to. So they're lines that you join up vertices that aren't next to each other. So this line here is a diagonal because it joins two vertices that are not next to each other. And this line here is a diagonal. It can be a bit confusing because the diagonal of a shape doesn't actually have to be a slanted line. It just means a line that joins non-adjacent vertices. Okay, so we see those two lines are inside the shape. So that's another reason why this shape is convex. Now for the last one, it has no reflex angles. So remember, reflex angles more than 180 but less than 360. So a reflex angle, if I had something like this would be obtuse, and this red one here would be reflex. Now, because the angle sum of a quadrilateral is 360, it is possible for a quadrilateral to have a reflex angle. But if it has no reflex angles, it's convex. So that shape there in red, which I drew a parallelogram, it is convex. And similarly, all squares, rectangles, rhombuses, kites, they are all convex shapes. Let's look at a shape that is non-convex. So that would mean it has one vertex that points inwards towards the center of the shape. It would mean there is a diagonal outside the shape, and it would mean that it has one reflex angle. Of course, a quadrilateral can only have at most one reflex angle. So the shape I drew before for an irregular quadrilateral was non-convex. So this shape here, it's four-sided shape, but it is non-convex. So let's have a look at why. So let's start by looking at its vertices. Well, it has one here that's pointing outwards, and pointing outwards, but this vertex here is pointing inwards towards the center of the shape. So it has a vertex that does not point outwards. Let's look at its diagonals. So remember, diagonals are lines that join non-adjacent vertices. So this line here is actually a diagonal because it joins this vertex and this vertex here. So they're not next to each other. So then it has one more diagonal. In fact, all quadrilaterals have two diagonals, and this is the other diagonal, joining two non-adjacent vertices. This diagonal is outside the shape. So it failed the first point, it's now failed the second one. And the third one, it will have a reflex angle. This angle here, without measuring it, we know is going to be more than 180 and less than 360. So why is that? Remember, angles at a point, this whole angle here is 360. This angle in here, which is obtuse, it'll be somewhere between 90 and 180. So that means that this angle here must be between 180 and 360. It has a reflex angle, so it fails the third as well. So we call this shape either concave or non-convex. I don't care which you use. The reason I'm just mentioning concave is that the shape is sort of caved in here. That might be a way to help you remember. The shape's caved in, it's concave or non-convex. All right, sorry again for the long video. The first 3 people from my class to reference this video and say Freddo Frog, you can have a Freddo Frog. Thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.